I just wanted to walk you through a couple of more examples because we've been doing problems that have like, really pretty answers, and they're not always pretty. So say we had a problem like this. Say 2x equals 7y minus 17, and 5y equals 17 minus 3x. So you know from the get-go this guy's going to be trouble, right? So what's our first step when we're trying to solve this, say with substitution? You remember, we can't just go to town, right? We have to do something special with this. Right? We have to write it in standard form. So I need to rewrite this as 2x minus 7y equals minus 17, and then 3x plus 5y equals positive 17, like that. All right, now I can go ahead and solve it like I would substitution, not substitution, with the addition method. And I will pick, I'm actually going to pick the x's again because the numbers are smaller. And my goal here is going to make that a, let's see, 2 and 3. So 6x, and I'm going to make this one a goal of minus 6x. Okay, so this one I'm going to multiply by 3. And this one I'm going to multiply by 3. So this one I'll multiply by negative 2, and this one I'll multiply by negative 2, like that. Okay, so I've got 6x minus 21y equals negative 51. And 6x minus 10y equals negative 34. Is that right? That looks kind of right. Yes. Okay, that does look right. Yay, I can do math. All right. Add it straight down. That was a terrible line. It's because I'm distracted by stuff. So I've got 0 plus 31, minus 31y. So that's why these problems are silly. Not silly. Challenging and enthusiastically fantastic. No. This is what happens at the end of lecture, is my brain starts to go everywhere. Alright, so I got y equals, yuck, 85 over 31. Barf. Guess what? That's actually right. This is where you say, oh, I don't want to work this. That's not true. You say, this is what I'm very excited about because I have a sense of mathematical enthusiasm, and I'm so excited I can hardly stand it. Alright. Move that over there. Alright. So let's go back to our original problem. Which one do we want to multiply by 85 over 31? Neither of them. Let's go with this one. Let's go with this one because it's already solved for x. The x is already by itself on the left, so let's go with that guy. 7y minus 17. So 2x equals, I might need more than that. 2x equals 7 times 85 over 31 minus 17. Alright, so remember to do this. Multiplying. So 85 times 7 is 5659, 595. And minus 17 over 1, so I've got to get the 31 on the bottom. 2x equals 595 over 31 minus, and multiplication is super fun. Wait, I can multiply by 1, there we go. 21, 527. So 527 over 31. See, the point of this is just to let you know that yes, these problems do get obnoxious. So 595 minus 527 is 68. Alright, now I keep making that look like a 7. One. Now if I want to divide both sides by 2, rather than divide that by 2, I can multiply it by, is your brain gone? 1/2. So I get 68 over 62. Divide the top and the bottom by 2. So x equals 34, yay, over 31. So my solution is, as disgusting as this looks like, is 34 over 31 and 85 over 31. So you could always go plug this into your calculator, into the original equation, just to verify. If I got this on a test, I would probably go check and make sure it was right. But really, we just want to make sure that you know how to do fractions and stuff like that. So it's always good to remind yourself how to do this stuff. Okay. And as a reminder, if you do get fractions in the original problem, you don't have to be stuck with them. So say you had something like this. Y equals 1/6 x plus 2/3, and y equals 2/7 x minus 1. If you want to get rid of those stupid fractions, please feel free to do so. If you remember back, how do I get the 6 out of the bottom? What can I multiply the whole equation by to get the 6 out of the bottom? I can multiply the whole equation by 6, right? So this guy becomes 6y equals x plus, did you got it? Did you got it? What, 4? Why is my brain not working? 4, that's clearly right. Okay. And then I'm going to multiply this one on both sides by 7. So now I've got 7y equals 2x minus 7. So now I've got a nice, pretty little equation, that system of equations that I'm probably going to solve using substitution, because I say, hey, that x is practically by itself. Let me go ahead and solve for it. Okay, so let me subtract 4. Did I do that? Hold on. I don't like this. What's going on? Subtract my 4 from both sides. So I get x equals 6y minus 4. Remember how substitution worked? I know, it was so long ago. I can go use my other equation, this guy. 7y equals 2 instead of x, I write 6y minus 4 minus 7. So 7y equals 12y minus... See, this is a problem where it's much, much, much better to use substitution and solve it that way by getting rid of all the stupid fractions and to actually go through here and do it for realsies. Or to try to do it with all the fractions in place. So plugging in my, what's it called? Y. X equals 18 minus 4. X equals, what's that called? 13. Yeah. So I've got a solution here. And I think that's right. Yeah, that's right. Now, you can still run into word problems as well. Again, if I'm going too fast or something's not working, please don't hesitate to contact me and say, hey, you're crazy. Something like this. Say the sum of two numbers is 15. And if one is subtracted from the other, the result is 5. And then find the two numbers. Now, what always got me on this is I would always say, well, which one's which? It really doesn't matter. For problems like this, you're just going to use x and y. So if I have the sum of two numbers is 15, what does that mean? If I have the sum of two numbers is 15, that means that x plus y is equal to 15, right? Then if I say, if one number is subtracted from the other, the result is 5. So what does that mean? If one number is subtracted from the other, the result is 5. Now, I would always get caught up in this whenever I was studying this initially, and I would say, well, do I make this be x minus y or y minus x? The answer is, it doesn't matter, because I'm not giving you specifics. You're going to get the same answer. You just might have x is something and y is something else versus x is something else and y is something. I mean, your answers are going to be flipped back and forth. Instead of getting x, y, you're going to get y, x. But it's not asking you for any specific order. It just says, what are the two numbers that makes this true? So you can just pick however you want. So I would probably say, if one is subtracted from the other of x minus y, then the result is 5. Okay? So, there we go. So, I'm going to use substitution. Ooh, wait, I could use addition, because look how well that lines up. You just, oops, can't ask for more. So I've got 2x plus 0 equals 20. So 2x equals 20, x equals 10. And if I have x plus y is 15, 10 plus y is 15, so y must be 5. Now, does that make sense? I say that if my numbers are 5 and 10, the sum of those numbers is 15. Yes, 5 and 10 is 15. If I subtract one from the other, the result is 5. Is that right? Yep. So, that's how I've got my answer.